Hi, I am Yaman.
Hi, I'm Ceren. Our project is Lifesaver Detector.
The main problems that led us to release this project are difficulties in accessing the living creatures under wreck in a short time and difficulties of determining the location of the living creatures when they are incautious and under difficult wreckage conditions. Finding the disadvantages of the devices used in the detection of living creatures.
We designed this device to reach people alive in a short time by determining the heartbeat and respiration of the people who were under the rubble, even if they were inactive. So what's an earthquake? An earthquake is the shaking of the earth by vibration caused by breakage or rupture events occurring in the earth's crust.
Here we see the earthquake risk map in Turkey. According to the research, when living things under debris are reached in the first half hour, the probability of survival is 91%, while at the end of the 5 days, this figure decreases to 7.4%. The average duration of survival under debris is 5-6 days. Search and rescue dogs, acoustic signals, and physical search and rescue with humans are the primary methods used to locate disaster victims.
An example of a seismic acoustic listening device is the Digital Life Detector LD3. The Digital Life Detector LD3 transforms the entire collapsed detector into a large, sensitive microphone that transmits sounds from the disaster victims.
The KL life detector is currently one of the most widely used radar life detection devices.
Lifesaver Detector comes to the fore with its detector, microcontroller, software, and sensor. In our project, we use Raspberry Pi as a microcontroller. Our sensor doing non-contact breathing following. It measures the distance between the living and the sensor. It can measure day and night regardless, and measure respiration rates.
By this project, mainly used Python language. Methods. In the project, we use the breathing sensor, Raspberry Pi 2B microcontroller board, screen and power bank. In the project, we designed the live detector, made the software of the live detector, extracted the 3D output of the live detector, and performed the assembly of the device.
The shape of the main body of the device, which covers and protects the existing parts and provides useful use, was drawn and printed in three-dimensional text. Preparation of prototype and or device.
Findings. We made measurements of 1, 2, and 3 people without disabilities. Here the peaks indicate the location of the living creatures. We positioned our 5 cm thick barrier at a distance of 20 cm from the sensor and performed our single person measurement.
The measurements for one person and two people, which we made using an 8 cm thick barrier, are given here. We positioned our optical at a distance of 20 cm from the sensor. Our device has detected the locations correctly.
The measurements for 1 and 2 persons, which we measured using the 17 cm thick barrier, are shown here. We positioned our obstacle at a distance of 20 cm from the sensor. We can say that as the barrier thickness increases, the signal loss increases in the measurements.
Thanks to the screen located on the prototype of the Lifesaver Detector, the distance of the creature to the sensor can be seen. In measurements taken from the computer, the distances corresponding to peak points formed in a position where the living creature is located are displayed numerically on the screen on the Lifeboat Detector prototype.
The results and discussions we got from the measurements we made. A device has been designed that can determine whether people who are under debris in an earthquake can live or not, even if they are inactive, with respiratory monitoring. While there were no obstacles in front of the device, measurements were taken with 1, 2, and 3 people. It was determined that the device correctly detected the distance of the person from the sensor and the amplitude of the wave increased or decreased according to the distance, movement, and respiration of the person from the sensor. Obstacles of 5, 8, and 17 cm thicknesses were used. Although the thickness of the barrier is increased, the sensor can detect the creature at different distances. It was determined that as thicknesses increases, This signal weakens a little and the range at which it can give clear results decreases to 1.5 meters. For the 17 centimeter obstacle, the distance that the sensor can detect light decreases to approximately 1 meter.
Here are the references we used in making this project. Thanks to listening us.